Hello, madam. Good evening, madam. Can you hear me?
Yes, sir. I can hear you, sir. Good evening.
Yes, madam. Yes, madam. Just I was creating the YouTube link for our students, madam, for online.
Okay.
So that's why it took the 5 minutes time.
Okay.
So our students have joined, madam. Almost 56, 57 students have joined, madam.
Okay, sir.
Madam, I will make you as a co-host for this today's session,
Okay.
along with our faculty members also. I request all the students to mute your audio and video. So whenever there is a discussion, you can unmute your audio and video.
Good afternoon, sir.
Good afternoon, Manwar. I request all the students to please mute your audio and video. So once we start this discussion, during the discussion time, you can unmute yourself and you can interact. Munwar, all our faculty have joined, Munwar. Once you check.
Good afternoon, sir. Rajni,
Good
sir.
afternoon. Good afternoon. Good afternoon, Prasad, sir. How are you, sir?
Fine, sir.
Yeah. Madam Vinodini, madam, later I will give you the screen share option, madam. You can share your presentation through screen share, madam.
Now I can share it, sir.
Not now, madam. Once I introduce, then I will give you the screen share option for you, madam.
Okay, sir.
Sunita, madam.
Prachat sir has joined. Ah, yes.
Sunita, madam. Vindya, madam.
Good afternoon, sir. Prachat,
Good afternoon.
Vindya, madam.
Swati madam has joined. Swati madam. Hello, Swati.
Rajnikant, sir. Sorry to interrupt.
Madam.
Please confirm whether my voice is clear or any break is there.
Your voice is very clear, madam. Your voice is very clear, madam.
Okay, sir. Thank you.
Yeah. Thank you, madam. Prachat, Swati madam has joined.
లేదు సార్ లేదు.
Yeah. She is there. Yeah.
ఉన్నారా?
Yeah.
joined, sir. Madam has joined.
వచ్చారు సార్ ఉన్నారు.
Yeah.
మేడం నాగరాజ్ సార్
Prachat, you can admit anyone at any time to join also. So shall we start the session? Dear faculty members, so shall we start the session?
Yes, sir.
Hey.
All of you, please mute your audio and video. During the discussion time, you can unmute yourself, except the faculty members and our today's guest speaker. Please, all others, mute your audio and video. Richard, shall we start? I think we have 63 participants.
Yes, sir. Yes, sir.
Respected so now I'll start recording. Okay. Prachit, we are starting the session. Okay. If anyone in between comes, you please admit them, Prachit. Okay.
Okay, sir. Okay, sir. I will admit them and I will take this screenshot also.
Yeah, yeah. Thank you, ma. Thank you. Respected Chairman, Chalapati Educational Society, Sri Y.V. Anjaneyal Garu. Respected Principal Sir, Professor Ramarao Sir. My dear colleagues, my dear students, and our today's guest speaker, Dr. Vinodini Madam. Good evening, all of you. I welcome you all for this today's guest lecture on the topic UV spectroscopy. So we are going to have a brainstorming session, especially on the application part of the UV, where an emphasis is given on the Woodward-Fisher rules. So I requested Madam to specifically concentrate on this area of Woodward-Fisher rule so that it will be helpful for our students. Even though it is not a part of the PCA syllabi, we have incorporated this topic as an additional topic in our Board of Studies meeting. As per that, we are inviting the speakers to deliver the talk on these additional topics so that we could meet the course outcomes, we could meet the program outcomes, and we could reach the higher course attainments. So with this objective only, we have planned this guest lecture, Madam. Now I take the opportunity to introduce our today's guest speaker, Dr. C. Vinodini. So Madam is a faculty. She is working as an assistant professor in Sri Ramachandra University, which is located at Porur, Chennai. So Madam has finished his B Pharmacy from Adi Parashakti College of Pharmacy, Melmaruthu, Tamil Nadu in the year 2000. She did her post-graduation M Pharmacy in Madras Medical College, Chennai during the year 2002. And she did his PhD from the Faculty of Pharmacy, Sri Ramachandra University, Chennai. And Madam has put up total of 16 years of experience in teaching. Apart from that, she has 2 years of industrial experience where she is worked for Arcade Healthcare, which is in Chennai, as a research executive. So Madam is well versed and she has taught the subjects in the areas of both pharmaceutical chemistry and pharmaceutical analysis. And Madam has several of the departmental responsibilities concerned with the universities and the Board of Studies of the university as well as the other universities. and she is actively involved in the instrumentation lab, where she has been the in charge for the instrumentation lab. She has undertaken consultancy analytical services, especially in the area of HPLC as well as IR. And Madam is a coordinator for the B Pharmacy program, and she is also the faculty in charge of continuing pharmacy education program at Sri Ramachandra University. And currently, she is a member of the admission committee. She is a student advisor. She is a member of the discipline committee, and she is also the member of faculty research promotions committee. And her areas of research include method development and validation of raw materials, active pharmaceutical ingredients of the various pharmaceutical products, stability studies, and she has an hands-on expertise in the area of HPLC, FTIR, as well as the UV visible spectrophotometer. Madam has guided B Pharmacy projects, M Pharmacy projects, and currently she is guiding on PhD student for a full-time PhD program. And she is also involved in the inter-department projects. And Madam has research grants to her credit. Totally, she received 3 intramural GATE Young Faculty Research grants. And Madam happened to be the principal investigator of the GATE Young Faculty Research Grant, which was awarded to her during the year 2018-19. And she has received the honor from the Ramachandra University for the best employee on the occasion of the Employee Appreciation Week. And she received that award from the registrar of the Ramachandra University. And her publications give a very good idea about her interest towards research. She has published 24 research papers in national and international journals. And Madam also presented several of the papers in the various conferences, seminars. She has actively participated in the workshops that were held at regional level as well as national level. So these are with this few introduction of Dr. C. Vinodini Madam. So now I request her to present the topic to our students. In this context, I request my students, also I request the faculty members to please coordinate to actively interact with our today's guest speaker and utilize the session very effectively. If you have any doubts, if you have any queries during the session, please post it in the chat box so that we can take up the queries at the end of the session. Thank you. Now I request Vinodini Madam to share her screen and present her topic. Thank you, Madam. Thank you all.
My screen is visible, sir?
Yes, Madam. Please, Madam. Go ahead, Madam. It is visible, Madam.
Okay. Good evening and my respects to officials of the management, principal, HODs, professors, and fellow fraternities and dear students. First and foremost, I would like to express my sincere thanks to Principal Sir for giving us this opportunity. It's a great opportunity for me. And I fail my duty if I am not mentioning Mr. Rajinikanth Sir name here, who is HOD of Pharmaceutical Analysis and very good friend of mine, for proposing me as a guest speaker for this day. Sir, I tried my level best to justify your proposal and give my best to the greater extent that students will benefit definitely.
Thank you, Madam. Thank you.
So, and also I thank you for the very extensive description of my biodata to the audience. And with this, can I move on to the session, sir?
Please, Madam, please go ahead.
With the blessings of my gurus, teachers, and my family members, I take over the session. And before I move on to the session, I would like to give very few instructions to the students. Can I go ahead with the instructions, sir? You have given already a few instructions, so I thought
Yes,
I can just repeat it quickly.
Please, Madam. Yeah.
So students, you all have been participating in many online classes as well, the webinars for the past 4 to 5 months, right? And I believe that you all will follow definitely the virtual class disciplines. And my request concern to this is please mute your audio and video during the session. And in case of any questions you wanted to post, please use the chat box. And I request Ms. Rajnikant sir to give, to just coordinate with me in giving the answers if anything posted by the students,
Sure, sure, madam.
if I pointed them with some questions during the
Sure,
session.
madam. Sure.
And also another request is please have a notebook or paper and a pen with you along with a calculator if you have. It is not compulsion now, but it will be better for easy workouts and for your understanding level. And the last instruction is really an embarrassing for a student. Anyhow, I have to tell this. I'm going to give you 2 assessment link through the Google form, which will be posted at the end of the session in the chat box. It's all just questions that I have given to you based on the content of the lecture I'm going to discuss to you all, right? So please don't get panic for that. It will be very easy if you have keen interest on looking to the session and observing it, right? And I have planned the session on 3 categories. The first category is on fundamentals or terminologies that is used in spectroscopy. And the next part, we moved on to calculations pertaining to spectroscopy. And the last session, as per the request of the organizer, I would go with the problems related to Woodward-Fisher rule. Before I move to the actual session, can you please that my voice is clear and
Your voice is clear,
okay?
madam. Please proceed, madam. Yeah.
So I personally believe as a teacher, when any lecture is to be given, it should actually start with proposing the learning objectives. As rightly said by Rajnikant sir in the beginning, objectives and outcomes should relate each other. And as a teacher, when we propose any session or lecture, the first thing the teacher-oriented work is to frame the learning objectives. So the learning objectives, what it deals with is how to conduct a class, what all things will be discussed in the class. That is the objective. What is the outcome? Outcome is nothing but what the student can do at the end of the session. What all the things that student will be able to perform at the end of this session. So when you generally look into the outcomes, it is classified as theoretical outcome, practical outcome, and intellectual outcome, right? In the other way, I just wanted to take you towards the domains of learning process. The same theoretical, practical, and intellectual outcomes is defined in a different way as knowledge component, skill component, and attitude component, which obviously deals with cognitive, affective, and psychomotor skills. So what do you mean by knowledge component? Let me explain with respect to our own subject of interest today, that is pharmaceutical analysis. When you look into the syllabus, as sir said, with respect to B.Pharm or PharmD syllabus, mostly your knowledge component will be based on principles or concepts or fundamentals that is related to a particular technique. And what is skill component is nothing but the technique that you have learned, how you are going to practice in a simulated laboratory environment. That is a skill component. And attitude component, how far better the student has a knowledge and skill to apply it in a real situation. So how best he can choose the analytical method, because we are available plenty number of analytical methods, and you have a right responsibility as an analyst to select a particular method that you can employ into the system. For example, I can better differentiate here the B.Pharm syllabus and the PharmD syllabus. As you all know that B.Pharm students are industrial oriented and PharmD students are clinical oriented, right? So B.Pharm students has to be taught by the teacher in such a way that applications are mostly towards the formulation and dosage forms, which is related to the industry oriented contents. But the PharmD students has to be taught with the applications which is based on the clinical perspective, which means how the analysts perform the analysis in a biological samples. So in that way, teacher has to give the lecture to the students so that the student will get well versed with respect to knowledge component, skill component, and attitude component. And I would like to express here some of the verbs, because verbs are very important when you frame the learning objectives. And not only teachers, of course, students should better understand the value of these verbs. See, generally, I hope that students knows about the verb explain, describe, differentiate, classify, and all these things you have already come across in your question papers, right? But when analysis point of view, it is very important that you should able to differentiate these verbs like analyze, express, handle, then interpret, calibrate, validate, relate, measure. So these are specifically confined to pharmaceutical analysis subject, and request to faculty members also to mostly use these verbs when setting the question paper. right? So a simple example I can give you. For suppose you are asked, how will you handle cuvettes during spectral analysis? This is the objective. That is the verb which is used here is handle, right? So the student is supposed to give the practical experience or the standard operating procedures that is he has to follow during the handling of cuvettes. That is important. Unless if the student is giving the description of the cuvette, explanation about the cuvette, it is not the appropriate answer. So you have to understand the verb rightly and then put the answers in your papers. So these verbs you can even infer from the taxonomy called as Bloom's taxonomy, which describes very many verbs, and you have to rightly choose the apt verb for your learning objectives. And I think you're all aware of this definition part. So quickly I will give the recall on the subject. So the subject is basically a branch of science that comes under branch of chemistry, in turn comes under branch of pharmaceutical chemistry, and pharmaceutical analysis comes under the branch of pharmaceutical chemistry, in which we are concentrating on two main areas. One is identification, other one is quantification. So what we have identified, what we have quantified is nothing but a solution or a mixture is generally analyzed to determine the active constituents that is present. Not only active constituents, you can even go stretch your analysis towards the impurity or any other additives that is present in a dosage form. So I'm not detailing this, just giving you a rough idea. And in your first year program, you would have been familiar with these terminologies like molar, normal, percentage, assay, percentage purity, actual molarity, molecular weight. So at the first year level. But now in the final year, you have to be familiarized with some non-familiar terminologies like absorbance, percentage transmittance, absorptivity, molar absorbance, which comes under spectroscopy, and also some other terminologies like retention factor, retention time, theoretical plate, scaling factor under chromatographic techniques. So as far as your analysis is concerned, we are more confined to a semi-micro analysis. So you should have a knowledge of describing different types of analysis based on the size of the sample. Say for example, macro, semi-micro, micro, sub-micro, ultra-micro. It all depends upon the size of the sample that is used for the study. And semi-micro analysis is one widely used because of the compatible usage of the quantity of the sample, 10 to 100 milligrams. So, and this slide depicts the difference between the qualitative and quantitative. Can you give me a quick response about qualitative and quantitative? Any one student can post in the chat box. What is the difference between qualitative and quantitative? At least from the slide, looking into the slide, you can see.
You can unmute, students, you can unmute yourself and you can tell, any one of you, please.
How much purity of the compound is qualitative, ma'am?
Okay.
How much purity is qualitative? You are correct?
Purity. Okay.
How much, that means quantity, isn't it?
How much quantity, ma'am? Quantity, how much amount is quantity? Purity of the substance is qualitative, ma'am.
Whether it is present or not, right? So when a fisherman is searching in a sea, a large ocean, for the presence of precious stones, then it becomes qualitative. So after finding out its presence, if you're going for estimation about the purity of the stone, then that becomes a quantitative analysis, right? So identifying is nothing but qualitative. Not only identification, but it extends to estimation, then that becomes a quantitative analysis. So this difference definitely a basic answer that a student is expected to give in a Viva. This difference everybody should know. And let me just go with another example. For example, Dolo 650, you all aware of this drug. What is the active constituent present in this drug? What do you mean by APA, active pharmaceutical ingredient, isn't it? That is responsible
Paracetamol.
Paracetamol. Exactly, that's correct. So presence of paracetamol, how can you identify the presence of paracetamol? By performing simple chemical test or by measuring its melting point or boiling point, or a simple limit test can help you to identify paracetamol in the Dolo 650. But when you move on to quantitative application, as we have many different types of instrumental method as well as non-instrumental methods available, the quantitative analysis purely depends on the estimation part, where the amount or purity of the paracetamol is the scope in Dolo 650. So when you identify, it becomes qualitative, and if it is quantitative, you have to measure its amount or purity or simply a concentration. So this is the difference, basic difference between qualitative and quantitative. And also you should able to understand what is drug substance and drug product, because we mostly employ analytical methodologies to these areas. So drug substance is nothing but bulk drug or active pharmaceutical ingredient which is responsible for giving the therapeutic activity. And drug products are nothing but formulation. So you can convert a raw material into formulation by incorporating excipients or additives with them. So it is also very important analyst to analyze the excipients additives along with the dosage forms. Not only excipients additives, it also extends to the analysis of solvents which is involved in the methodology, chemical reagents, buffers, impurities, which all plays very important role in the drug analysis. And now let me move on to the actual part of the first part of the lecture, that is fundamental of spectroscopy. So this is purely a knowledge component. So the learning objectives for this session goes like this. So at the end of the session, the student will be able to define spectroscopy, enlist the types of electromagnetic radiations. Few I'll read out, not the all. And you can able to predict lambda max in a given spectra. You can relate lambda max with concentration. And also you will aware of some terminologies like absorbance, transmittance, specific absorbance, and molar absorbance. And then also you can identify chromophoric and oxochromic groups. And finally, you will be able to plot the calibration curve with respect to spectroscopic and other chromatographic measurements as an example I've taken. So I always love to give some pictures to the students and find out to play connections kind of thing. I hope that you're all aware of connections. It's nothing but you have to connect the pictures and give me the terminology. So let me see if anybody is posting the chat box, I'll be happy. Please go ahead with the pictures and connect the word and give me the terminology, what it could be. What it could be? Any idea? So this is nothing.
UV spectroscopy.
Yeah, come again.
UV spectroscopy.
UV. What is this? This stands for, who is the person on the picture?
Bill Gates.
Bill. Okay, Bill Gates. That's right. Rightly pointed out. Identified. Very good. So this is nothing but UV visible spectroscopy. So this kind of activities I used to give in between when I take classes to the students. So who has identified that? Rajnikant sir, can you tell
His name, I think, is
B-Farm or PharmD student?
B-Farm student, madam.
B-Farm student. Okay, that's a good
Shanmukh,
try.
is it Shanmukh Srinivas?
It's a good
Yes,
try.
sir.
That it's a good try. If you're well versed in the terminology, you can easily identify. Otherwise, it's very difficult.
Yes, ma'am.
So the definition goes like this: two things are involved. One is matter and the light, according to spectroscopy. So simply the light is being rephrased here with electromagnetic radiation. And as you all know that what is matter, solid, liquid or gas. So it is nothing but interaction of an electromagnetic radiation with that of the matter is a study of spectroscopy. So you should able to define spectroscopy very simply with these statements. And what is electromagnetic radiation is nothing but the radiations that is coming from the source which has electrical field and magnetic field towards the direction of propagation. So as it is requested, I am not going detail into the very basic things as we don't have time to look into the problems. So I'll quickly move on to this electromagnetic spectrum. So what knowledge the student should have here is, so you know this electromagnetic spectrum consists of different radiations like visible, ultraviolet, X-ray, gamma, infrared radio waves, and you have a role to position where the visible light lies, where ultraviolet. So you keep the visible in the center and stretch towards left as well as right side. So left to visible is ultraviolet and right to visible is infrared. And moreover, you should have an understanding that as the wavelength increases, the energy decreases. So here you infer that energy is inversely proportional to that of the wavelength. This is the basic knowledge that you should acquire from the electromagnetic spectrum. That is, increase in wavelength decreases the energy. So according to Einstein equation, you all know that E is equal to h nu, where energy is inversely proportional to the wavelength. So then next is some characteristic units of EMR. So I'm just going quickly to the 3 units, wavelength, which is represented by the symbol lambda. It is nothing but distance between 2 maximas and minimas. So when a wave is passed, then it is separated by individual waves, and distance between 2 maximas or 2 minimas. Otherwise, it is called as 2 crest and 2 troughs. It's nothing but the wavelength. So what is the knowledge you should have here is, generally the lambda is expressed in terms of nanometers, and also it uses Armstrong or millimicron as a unit, and especially this particular characteristic unit is used in visible UV, atomic absorption spectroscopy, flame photometry, and fluorimetry. So you should aware that this particular unit is used in what all spectroscopics, and also you should know how to convert the nanometer to meters or millimicrons to Armstrong, and these skills you should also have with you. Then the next unit is nothing but wave number, which is represented by the symbol nu bar, and it is inverse of wavelength, that is opposite, indirectly proportional, and it is generally measured with the unit centimeter inverse. So what do you mean by wave number? Wave number is nothing but in 1 centimeter, how many number of waves are passed. You can look into the picture. So how many number of waves that passes through 1 centimeter is called as wave number. And especially where you have to use this wave number characteristic units, it is used in IR spectroscopy. So you're not supposed to use wavelength in IR spectroscopy and wave number in UV spectroscopy. So that attitude you should have, where it has to be applied appropriately. So that knowledge is very much important as far as student is concerned. The next is frequency. The frequency is nothing but number of waves that passes through a point in 1 second. So within a 1 second, how many number of waves that passes through one point is nothing but frequency. It is generally expressed in terms of seconds as well as hertz. And this particular unit is used in NMR and ESR, that is nuclear magnetic resonance and electron spin resonance spectroscopy. So again, one more task I wanted to give. Can you identify this terminology? If a student is able to
Beer-Lambert's law.
Very good, Beer-Lambert's law. That's extraordinary. So Beer-Lambert's law. So can you tell something about this law? Anyone? What does this law states? It's a fundamental laws of absorption of light, right? You would have derived the law to the maximum extent, and you would have listed the deviations of the law. And now you tell me quickly, can you tell me a short form, what it relates? What it relates?
How the concentration and length of the cuvette deals with the spectrum.
Deals with the spectrum or absorption?
Absorption.
Absorption, very good. So you are going to relate the absorption and concentration towards the thickness, isn't it? So when absorbance is related to thickness, that becomes Lambert's law. When absorbance is related to concentration, that is Lambert's law. So combined law also is available. So I'll just quickly describe the working principle of the spectrophotometer. And you are aware that source is the first components of a spectrophotometer, from which intensity of incident light. What is I0? Intensity of incident light, right? So when you look into this incident light, it is of polychromatic in nature. Now you have to understand what is polychromatic light. Look at the picture at the down. Polychromatic light is nothing but light of many wavelengths. See, different wavelength. Light of different wavelength is polychromatic. But you are not supposed to pass this polychromatic light into a sample holder. So before you pass this light to the sample holder, the polychromatic light is to be converted into a monochromatic light. MCL stands for monochromatic light. So now tell me, how will you convert a polychromatic light into monochromatic light? Please answer. How will you convert polychromatic? Polychromatic means light of many wavelengths. But the light that you are supposed to pass to the sample is monochromatic, light of single wavelength. So how do you convert? Can you give some, can you add up some components in between light source and the sample cuvette?
Like filters,
Yeah?
Nicol
Filters.
prisms,
Yeah, very good. Filters, prisms, anything which is more
monochromators.
Monochromators are a general term, like wavelength selector, monochromators, dispersing device. I want one more, the last option, apart from filters and prisms, which is more resolution, which gives more resolution in the spectrum compared to prisms and filters. That has rulings on the surface, grooves on the surface. Exactly, gratings. Yeah. Very good. Very good. Gratings. So these dispersing devices are employed to convert the polychromatic into monochromatic. Now what happens? A monochromatic light passes to the sample, and sample, based on the concentration or based on the thickness of this. So two things involved here: concentration with respect to solution that is filled onto the cuvette, and thickness is related to the sample cell that you have used. So the light that passes onto this get absorbs, which is based on the concentration as well as based on the thickness. And after absorbing, the unabsorbed light, or you can call it as a transmitted light, right? IT stands for transmitted light, will reaches the detector. So what the role of detector is, detector measures this transmitted light and it converts that light energy into an electrical energy. So you have very many different types of detectors: photo multiplier, photodiode, and barrier layers, and so on. So these detectors will convert the light energy. What is the light energy that is transmitted here? From the cuvettes, isn't it? So that will convert the light energy into electrical energy. And what is the next accessory to the detector? Can anyone fill up the next accessory? Yeah.
Readout device.
Readout device, ROD, or otherwise called as amplifier, right? So what is the role of amplifier? Amplifier will already collects this I0, and now it collects the IT from the detector, and when you subtract I0 from IT, it gives the absorbance. And obviously the absorbance is in the form of energy. It has to be converted into a numerical value. So that is the role of an amplifier. So light source will generate light of required radiation. The dispersing device will convert polychromatic into monochromatic light, and that light will pass on to the sample where absorption takes place, and the unabsorbed light in the form of transmitted light will reaches the detector, and the detector will convert the light energy into the electrical energy, and then further it goes to the amplifier for the conversion of the energy in the form of numerical value. So the best thing that you obtain from the amplifier is nothing but a transmittance or the absorbance. So this is a quick review on understanding the Beer-Lambert's law. So you can see here the expression that relates Beer's as well as Lambert's law, where absorbance is directly proportional to thickness and where absorbance is directly proportional to concentration. You are able to see the movement of the cursor? Anyone please acknowledge? Are you able to see the movement?
Yes, we know. I can see. Yes,
Yeah,
yes,
okay.
please. Yeah.
So the combined law is nothing but absorbance is directly proportional to thickness and concentration along with the proportionality constant. Now let us look into the practical aspects. So the same picture I've depicted here, you have a source, sample, cuvette and detector. So if nothing is placed, say for example, when you get the exact I0 out of the sample cell, when nothing is there, no concentration of the sample is filled or thickness is not at all related to it. So then you will get the 0 as incident rays. But if you keep sample in the cuvette, then your I0 now it becomes the IT. So this is the difference. So when you keep a transparent solution, you won't get any absorbance value. And if you keep any solution which has a specific concentration and has a chromophoric group which are responsible for the absorption, definitely your I0 will not be I0. It is something else, that is the transmitted light, which is represented as IT. So as a student, you should know what is I0, IT, IA, and all these expressions should be thorough to you, right? And this is what I just explained. And now let us see the Beer-Lambert's law and specific to the path length dependence. So you have a source here, light is passed and there is no absorbance because you don't have any sample in between, right? So you have absorbance 0. Now you let us see what happens when I keep sample of thickness. B is the letter which represents thickness. So with the appropriate thickness, you can see some absorbance, isn't it? Because Lambert's law says this absorbance is directly proportional to thickness, right? So in the previous case, no thickness is employed, no concentration. So it is 0. Now you have employed thickness, say for example, 1 centimeter or 2 centimeter, then it gives appropriately the absorbance, which is meant for that. And now you see, I have placed 2 cuvettes, right? So it doesn't mean that we have to keep 2 cuvettes on the same path. It is very unobvious to keep 2 cuvettes on the same path. You can have 2 cuvettes on the 2 different path in case of double beam spectrophotometer. But in a single path, you cannot keep 2 cuvettes. This actually means you are doubling the thickness of the cuvette, not you are keeping 2 cuvettes. Doubling means instead of 1 centimeter, you are replacing it with 2 centimeter cuvettes or 3 centimeter thickness of the cuvette. So obviously when you increase or double the path length, your absorbance also is increased. Can you see here? Previously it is 0.22, now it is 0.44, right? And what happens when you keep 3 centimeter thickness, then it becomes 0.66. So here you should infer that as the thickness varies, absorbance also varies. That is what actually proven by Lambert's. right? And also please understand that you are not keeping 3 or 4 cuvettes at a stretch. It is nothing but increasing or doubling or tripling the thickness of the cuvettes. And next, let us move on to the concentration dependence. Here you can see a sample is placed and you are able to observe the absorbance at 0.42. And now you compare this with the previous one. Why there is increase in the absorbance? Can anyone say? Thickness is maintained constant. So that is a hypothesis I am giving to you. Here the thickness is kept constant. This is the first.
Concentration have been increased.
How did you say that concentration is increased? How did you say? I
Is
have
it
shown
in
this.
absorbance?
A change in, how did you identify it? Of course, change in absorbance. How did you identify it?
The relationship between absorbance and concentration is directly proportional.
The color has been in depth.
Yeah, that is what I exactly required. Color is being intense. Can you see here? This is light blue, whereas the next one is dark blue. So as the color intensity increases, why the color intensity increases? Because of the increase in the concentration of the solution. Thereby your absorbance also increases. This is according to which law? Beer's law. Is there any Form D students answering to the session, Rajani? May I know the audience? Is the B Form or Form D students? You please unmute. I'm not able to hear you.
Presently, B Form students are interacting. Yeah.
Okay.
Yeah.
Okay. So because of the increase in the intensity of the color, the absorbance is increased. Now you can see here what you observe from here. The blue solution do observe the red. The light that passes should be of red. Red light only can absorb by the blue solution. And at the same time, the red light cannot be absorbed by the red solution. So this you can understand by having the knowledge on the color wheel. Please look at the left side of the slide where I proposed the color wheel. So color wheel consists of the Vibgaya, that is rainbow colors, violet, indigo, blue, green, yellow, orange, and red. Generally, it is been devised diagonally into 6 parts. The 6th part is nothing but your violet, indigo, which is together, and rest of the colors are one after the other is placed. And the wavelength range also given. Say, for example, your solution of the color is red. So which filter you have to choose? Complementary means just opposite to the diagonal. So if your color of the solution is red, then you have to select suitable filter which is of green color. If it is yellow, you have to choose violet. If it is orange, then you have to choose blue. So near blue, far blue, like that, it varies according to the color of the solution, because always we won't get a thick or dark red color. Sometimes it may be light red color or it may be dark yellow color. So based on that, your wavelength range also varies. So this color wheel infers you the different wavelength for different colors. At the same time, you have to use this color wheel to select the filters of choice for your measurement, right? So this I wanted to insist, because you're passing the red light to the red solution, so you can't see any absorbance here. Whereas when you pass red color to the blue solution, you can observe the absorbance. And next terminology that I'm going to move on to is absorption maximum, lambda max. And many times I observed from the student, when I ask them to define lambda max, they say it is, they know lambda is wavelength, right? They say it is a maximum wavelength. It's an unwrapped answer. It is not the maximum wavelength. It is a wavelength at which maximum absorbance is measured. So please have this difference. So it is nothing but a wavelength at which maximum absorbance is measured. So generally, how you draw the spectrum? Spectrum generally is drawn with x-axis, y-axis, right? X-axis is abscissa, y-axis is ordinate. And always you should have a knowledge that in x-axis you have to give the known parameter, and in y-axis you have to give the unknown parameter. What is a known parameter? What is a known parameter? Because you know which wavelength you are going to scan, isn't it? So that is a known parameter, which is wavelength. The other one is absorbance, which is nothing but an unknown. You are going to measure it. You are not knowing it at the initial level. So that is unknown parameter, which has to be plotted in the y-axis. So this is generally how a spectrum is plotted, by using the intensity of absorbance versus the wavelength, right? So based on the wavelength range, you can say whether it is a UV visible spectrum or it is UV spectrum or visible spectrum. So for that, you should have a knowledge on the range of the spectrum. So for UV spectrum, what is the range? It is 200 to 400 nanometer, or exactly if you want to say, it is 185 to 400 nanometer. And visible spectrum is 400 to 800 nanometer. So by seeing the wavelength range, you can identify whether it is UV spectrum or visible spectrum, or it is UV visible spectrum. So can you tell me, the first one is UV visible spectrum. Can you tell me Can you predict the lambda max from the second image? Any one of you? So as I said, lambda max is nothing but the wavelength at which maximum absorption is observed. So from the second image, can anyone predict the lambda max?
471 nanometers.
471, because it is a wavelength at which maximum absorbance is absorbed. And the
Now,
next,
we know now PharmD student also responded.
okay,
Yeah.
thank you. I'm happy for that.
Thank you.
And next is the next this picture depicts what? It's overlay. So why this overlay is being carried out? Because to compare the different samples, whether they have a similar spectrum or the spectrum varies with some additional peaks, or any missing of peaks is there, or blood spectrum is obtaining. So all this information you can infer when you overlay one spectrum over the other. So here you can see aqueous extract is overlaid with the standard as well as the alcoholic extract of some samples. That is satavirin is a sample which is used. So this slide infers you should have a basic knowledge what is absorption maximum, and also you should have a skill to identify the lambda max when a spectrum is given, and also you should able to differentiate the spectrum from UV and the visible based on the wavelength range. And the next thing is we are going to relate the lambda with respect to concentration. The statement says that lambda max is independent to concentration. So there is a series of solutions that is prepared. Series of solutions means they vary in the concentration. Say for example, you have a blank without sample. Blank is nothing but something without sample. Everything will be there except the substance. And the next is 5 micron, 10 micromole, 15, 20, 25. So there are different standard solutions are prepared, and when they are scanned in 200 to 800 nanometer, you are able to see the overlay spectrum. And what you can infer here, as the concentration increases, absorbance increases. Yes or no? As the concentration increases, absorbance increased? Yes or no? As the concentration increases, absorbance increased?
Yes, ma'am.
Yes, absorbance increase. You can see the increase in the height of the peak, right? So absorbance increases, but look at the lambda. What happens to the lambda? It remains constant. Lambda is not, yeah, lambda is not shifting at all. It remains constant. So you can see, you can say roughly it is around 580 nanometers. So in all the spectrum, lambda max is 580 nanometer, but definitely not the absorbance is same. So you can infer from this pictorial notation that lambda max is independent to concentration, but concentration is dependent on absorption according to Beer's law, right? Shall we move on to the next terminology? Up to this, you all are clear?
We we have another 45 minutes, we know.
Okay. Okay.
Madam, another 40. Yeah, please. Yeah.
So next terminology is absorbance. So these are the various formulas that are proposed. So why I'm just touching this, Rajnikant sir, because unless otherwise they don't know the formulas, they could not be able to work out on the calculations.
Yes.
So I'll quickly finish it off to the most extent that I can able to do it. So in case of some 10-15 minutes, if I'm stretching, please bear with me.
Okay, madam. Okay, sure.
So these are the formulas generally employed to calculate absorbance, like minus log T, 2 minus log percentage T. And transmittance is nothing but you can calculate with the expression that absorbance is inversely proportional to transmittance. And another terminology is specific absorbance, which is generally represented by the expression A 1% 1 centimeter or small a. So what is that? It is nothing but absorbance measured for 1% solution in 100 ml, right? So 1% means 1 gram in 100 ml. So when you measure absorbance of 1 gram of solution in 100 ml, then whatever the absorbance you arrive at is nothing but specific absorbance, and it's a constant value, right? So what is the formula employed to calculate specific absorbance is, according to Beer-Lambert's law, you know A is equal to ABC or KBC. So A is the specific absorbance. So you can give the formula as small a is equal to capital A divided by BC. So you have to know the difference between small a and capital A. Small a is absorptivity, which is a constant value. That is A 1% 1 centimeter value. Whereas the capital A is observed absorbance that you have to measure from the instrument, right? So this information you should aware. And the next is molar absorptivity. How it differs from specific absorptivity is, here 1 molar solution is measured for its absorbance. In the previous case, it is 1% solution, whereas here it is 1 molar solution is used, and its absorbance is nothing but molar absorptivity value, and generally it is expressed by the expression epsilon. and the unit is moles per liters per centimeter. And this is a formula which relates what is Emax, molar absorptivity. What is small a, specific absorptivity. So this is a formula which relates specific absorptivity and molar absorptivity. Let us say how we have arrived at this formula. So you just take 1%. What is 1%? 1 gram in 100 ml, right? For example, let me explain with the sodium hydroxide. How will you prepare 1% sodium hydroxide? By dissolving 1 gram in 100 ml, right?
100 ml.
Right. That is for specific absorbance. What is 1 molar solution? 1 molecular weight in 1000 ml. With respect to sodium hydroxide, what is 1 molecular weight?
40 grams.
23 plus 16 plus 1, 40 grams. So when you dissolve 40 grams in 1000 ml, that becomes 1 molar solution. So absolutely these two solutions are different in their concentration. So when you relate these two things, that is Emax with A 1%, 1 centimeter, you will finally get this expression, that is molecular weight by 1000 is equal to 1 by 100, which is Emax is equal to specific absorbance. That is 1 molar solution in 1000 ml is equal to 1 gram by 100. And when you calculate it, you will be able to arrive at this molecular weight by 10. So you should aware how this 10 has come into the formula. This is how it has arrived. And if you want, you can go through later on in detail the steps that is been followed here. So Emax is equal to A into molecular weight divided by 10. Okay, the next task. Can I have some Form D students to answer this? What could be this terminology?
Any Form D students, please respond. Let us see.
If you are able to identify a bird, then it is easy.
Chromophore.
Yeah, chromophore.
Very
Very
good.
good. Chromophore. Chromophore is the, so what do you mean? What is the significance of chromophore in a spectroscopy? Any idea?
Responsible for absorption.
They're responsible for imparting color as well as absorption. So they're generally unsaturated, covalently bonded organic functional groups which are responsible for absorption. That's exactly right. So effect of conjugation is very important. So for any compound to get absorbed into a UV spectroscopy, you need a minimum conjugation. That is, minimum conjugation is nothing but a double bond separated by one single bond. Two double bonds separated by one single bond is nothing but a conjugation. And if you look into the left side structure, that is 1,5 hexadiene, which is non-conjugated, whereas the right side, which is 2,4 hexadiene, which is conjugated, and you can see the increase in the wavelength. So extent of conjugation or presence of conjugation will shift the lambda towards the longer side. So what is the name of that shift? When the shift is towards the longer side, what is the name of the shift?
Please answer. It's a very good terminology.
Bathochromic shift.
Bathochromic. So what is the other name for bathochromic? It is longer wavelength. You just imagine what is a red shift.
Red shift.
Yes, red color is the longest. Okay. So next we'll move on to the next terminology, is that oxochrome. So remember that oxochromes are nothing but the substituents which are incorporated into a chromophore, but they are not responsible for color formation. But what does that do? Oxochromes are responsible to shift your wavelength or to change your intensity. That is the role of oxochrome. So when you introduce any electron donating group or withdrawing group to any chromophoric group, so that makes the stretching of the absorption towards the higher side or lower side, also increase the that is molar absorptivity value to the higher or the lower side. So based on this, you have this example. So benzene has 255 nanometer where you don't have any oxochromes. But when I introduce this OH group, that is phenol compound, it is increased. And then still with amino compounds, it's still more increased to the longer wavelength. So when oxochrome is introduced, there may be shift in the wavelength. So that is, and greater electronegativity will shift towards the shorter wavelength. So oxygen is greater electronegativity compared to nitrogen, and you can see it is absorbing at the lower wavelength. It's all depends upon the electron cloud that is present. And if there are more electron, you have to give more energy. If you give more energy, then definitely it will absorb at the shorter wavelength. So that relationship you should know. So just I repeat here, being more electronegative oxygen, electron cloud will be existing there, and thereby it requires more energy for the excitation from ground state level to the excited state level. So because of that transformation, it requires higher energy, it absorbs at lower wavelength because energy is indirectly proportional to the wavelength, whereas nitrogen is less electronegative, so is absorbing at the longer wavelength. So these are the various shift, as I already said, red shift towards the longer side wavelength, blue shift towards the shorter side. What is hyperchromic effect? when there is an increase in the epsilon max value, when there is decrease in the epsilon max value, and so many factors are responsible for this. As I already said, electron donating group, withdrawing group, and then solvent effect, and mostly this inductive effects also plays role in the shifting of wavelength towards the either side. So with this terminologies, I'm just concluding this first part with respect to this terminology. Anybody can identify this? Can you identify this terminology? Which helps us to predict the concentration range. Say, for example, it obeys from 10 to 50 microgram per ml. You would have seen this words in the journals or in any procedure.
Shall I answer, Vinod?
Nobody is there. They have not posted in the chat box.
Yeah, once I'll check. Backup remission. No, still not posted.
Still not. Yeah, Rajani, please go ahead.
Linearity, is it linearity?
Yes, exactly. Lean. I've just put that girl for lean. She's looking lean. Linear T. Okay, if you know the terminologies very strongly, you can easily identify. I'm happy for you, Rajani sir. You still remember the terminologies. And this, I'm just going to explain you how the linearity curve is plotted. So in all the curves, you can see, of course, different techniques are used here, which is HPLC, flame photometry, fluorimetry, UV visible, atomic absorption. In all the cases, you can see the x-axis as concentration, and y-axis, of course, varies. In case of HPLC being a chromatographic technique, it becomes the area, and in case of flame being it's an emission spectroscopy, flame intensity is in the y-axis, and in fluorescence, fluorescent intensity, in UV visible, absorbance, as well as atomic absorption, it is absorbance. So y-axis varies parameters, but the x-axis remains the same. And how you are generally expected to get this linearity curve? The linearity curve should be a straight line, and it should pass through the zero. Mostly if it is passing through zero, it gives a better correlation coefficient. So maximum you have to see that out of 6 expressions, minimum 3 expressions has to fall onto the line. So these all you can infer from the ICH guidelines Q2R1, that is a validation guideline where linearity can be detailed more. So at this point, it is enough if you understand how to plot a linearity curve, and y is equal to mx plus c, where slope and intercept as well as the correlation coefficient gives you the statistical expression to state that how far your method is linear or not. So with this, sir, we are completing the first. I'm not able to switch over. So just quickly, I wanted to give these questions to the students for the first session based on the content that I've discussed. So students, can you please tell me which absorbs at longest wavelength?
1,3 hexadecimal.
1,3.
The answer they given is 1,3 hexadecimal, you know, in the chat box.
Yeah, please post in the chat box, because everybody will try to answer it, so that will disturb the audio. Rajnikant sir, can you please see the chat box and tell me it is 1,3?
Yes, madam. It is 1,3 hexadecimal, madam.
Yeah, because it is conjugated, whereas the other one is non-conjugated. So please go. Yeah, please go with the next molecule. The next question, A or B? Anybody have posted, sir?
B, madam.
B.
Some student, most of the students have posted B, madam.
B, yeah. So some of them have posted A.
A also, madam. Yes.
A is the wrong answer. B is the right answer. See, your conjugation has to be extended.
Yes,
yeah, conjugation has to be extended. Here the conjugation is lost. The double bond is separated by 2 single bonds. Whereas here your conjugation is extended. So obviously B will have a longer wavelength.
Okay.
Again, the same rule you can apply here.
Respond for question 3, ma, students. Longer wavelength.
It's all depends on the conjugation. Of course, it's a very big structure, but simple description, conjugation. Which structure has continuous conjugation?
That chromophore matters.
Chromophore matters a number of double bonds if you are connected rightly.
Yes.
Some structure there may be many double bonds,
given,
but they're
given B as an option.
Yeah, B is the right answer because you can see the conjugation extension, double bond, single bond, double bond, single bond, double bond. It is rightly
Yes.
connected. Whereas here you have only 2, it is not extended more. So that's the
Yes.
reason B will have a longer wavelength, right? And of course, this is quite the students who has organic chemistry knowledge can better attempt. So this application very much helpful for a synthetic chemist to see whether the reaction has completed or not as a basic study. Of course, we have to go for IR as well as NMR, the hyphenated techniques, but still to start with the basic research, you can even infer. So what is the reaction going on in the first category? Palladium and hydrogenation. So do you think this that is alkene will be converted into a saturated compound? That can happen, hydrogenation? Yes,
Reduction is going.
right? So this bond will lost. Just tell me whether this bond will lost. On hydrogenation, of course, CH double bond CH will become CH2. So it will give shorter wavelength. So compared to, if this conjugation is lost, obviously the lambda will be decreased, lambda max, right? Shorter wavelength. What is the next one? I can give you the chemical process that happens. It's an elimination reaction. You have to remove this Br as HBr. What happens when you heat this
Still
HBr
bin.
is eliminated?
We get a still bin.
Bond you will get in between. There is a
Double bond.
formation of bond, double bond. Yeah. So here the conjugation is there, right? Then single bond, then new bond is formed here, double bond, then single bond, then double bond. So it is connecting these two extreme chromophores towards a double bond in between. So the elimination reaction. So what happens to the wavelength now, you tell me, compared to the reactant product will have? Increased wavelength. That is correct. And this is again an oxidation reaction. So pyridinium chlorochromate, that is an oxidizing agent. Can you tell me what could be the oxidized product? So what happens on oxidation? Secondary alcohol will be oxidized to ketone. So conjugation is formed here. The product, double bond, single bond, double bond. I have not shown the product here, but I have given the description. So what is happening? Oxidation takes place. So ketone is formed. Since ketone is formed, the conjugation is exhibited here, and thereby it absorbs at a longer wavelength. Right? Shall I move on to the next question?
Yes, madam. Yes, please, madam.
Yeah, please tell me what is x-axis and y-axis quickly. Quickly, you tell me. X-axis is what? Wave. Y-axis? Absorbance. Yeah, predict lambda. Please put it in the chat box.
Yes.
Predict lambda max. Can you predict lambda max?
What is the lambda max? You put in the chat box, students.
It is 410 nanometer, right? And x-axis is wavelength and y-axis is absorbance.
One student has given 410, madam.
Yeah, that is a correct answer.
Yeah.
So I don't know. I have to rush out.
Still.
Am I rushing out? If you give some time, I can just interact more.
No, madam.
So
your frequency as they are in your frequency.
Okay.
Please continue. Yeah.
So, shall we move on to the next question?
Yes, madam. Yeah. Many of them has posted, madam. 410.
Oh, yeah. I'm happy that they already have the very good knowledge on this part.
Yes, madam.
Not due to the lecture, but still they have it before. So now can you tell me, just find out the complementary color, copper sulfate. You all aware of copper sulfate solution? What is the color of copper sulfate solution?
Blue.
Blue. What is the color of diazotized solution? Diazonium salt. Okay, it is yellow color. Just I'm giving you a hint. Copper sulfate is blue color. Diazotized solution is yellow color. Now you select the complementary color from the color wheel. So what wavelength I should select for copper sulfate? It's a blue color. If it is blue, you have to go with the complementary. Yeah, 600 to 640. And for diazotized, it is yellow. So you have to give the complementary color as 400 to 450. So if your solution is yellow, you have to choose violet filter. And if your solution is blue, you have to use orange filter. So this color will helps to fix the filters for any estimation. Okay. So can you identify the isobestic point? This I have not told in the session, but anybody have idea of isobestic point? Now I define it, then you can tell me. So isobestic point is the wavelength. It is a wavelength at which two different species will have same molar absorptivity. So you can see here two different species. One is red, other one is blue. Okay, two different species, and they have its own lambda max. So we are not bothered about the lambda max now. Now we are bothering about the isobestic point. Oh, just tell me what is isobestic point? The wavelength at which both the species will have same absorbance value. So where it can happen? At the intersection, right? So just look at here. You are able to see my arrow? This point, this is the point at which you can see the same absorbance for both blue as well as red component. Yes or no? Yes or no? At this point, you can see the absorbance of blue also same, red also same, right? So that is the identification of an isobestic point. And what is the significance of this point? You can even estimate the compound at isobestic point, where your level of impurities will be very, very less, because at this point, obviously your absorbance is less, right? Compared to the maximum, here the absorbance is less. Compared to this blue maximum, absorbance is less here. So for the analyte, the absorbance is less. Obviously, the impurities which is present in a very low quantity will definitely be ruled out from the analysis. So that is the reason we are sometimes using isobestic point to evaluate the drug analytes, right? So this is just. So now next question, can you just identify what is 1, 2, 3, 4? Can you give me the answer? So it's nothing but at least. Can you tell me what is 4? 4?
Hypochromic shift.
Hypochromic. What is 1?
Blue shift. Chromic shift. Blue shift.
Not bathochromic. Somebody answer.
Blue shift.
Hypsochromic. Right. Okay. Okay. I'll move on to the last question. So can you label the parts quickly? Light source. So this is one where
Prism.
you are able to narrow the. No, before prism, what is that number 2?
Chromator.
Before prism, what should be there? You have to narrow down your light and pass through this prism.
Slit, madam.
Slit, exactly. It is an entrance slit. You have two slits, right? So
Yeah.
entrance slit. Then you have a dispersing device. Yeah, somebody said prism, right?
Prism.
Then. Now, what is 4? 4. Please label 4.
Exit slit.
Exit slit. Okay. Now you see after exit slit, what is coming out? The polychromatic light is now coming as a monochromatic light, right? That is what I was talking in the previous slides. Then what is this fifth one is? Cuvette, otherwise sample holder. Yeah. And what is the next to last one is?
Detector.
Detector.
Yeah, that's correct. So now let us move on to the, should I give some gap or I can continue, Rajni, for the part 2 session? Calculations in spectroscopy?
No, you please continue, madam.
Okay.
Please continue, yeah.
So at the end of the session, hopefully the student will be able to calculate these parameters like energy, wavelength, wave number, frequency, absorbance, transmittance, concentration, absorptivity, and molar absorbance. Please have your notebook beside you, or you can keenly observe for this. So this is the first question. So as soon as you, I
request the students to please keep the calculators ready so that immediately you can post the answer, right? Thank you. Continue, madam, please.
Actually, I've already given the answer in the slide. If they want, let them work out for the acknowledging the correct answers. Okay. So when a question is posted, always you are asked to read the question carefully. And then first step that you have to do is, what are all the parameters that is given in the question? So when you look into this question, the one and only parameter that is given to you is wavelength, isn't it? What is 234 nanometer? It's a wavelength, right? Then what is the task given in the question? You have to calculate the frequency of a photon in hertz. In this unit only it is required, right? And then you are given another task, which is energy has to be calculated in terms of kilojoules per mole, as well as you have to express the energy in terms of electron volts. So there are 3 tasks given. You have to calculate frequency in terms of hertz. Also, you have to calculate energy in terms of kilojoules per mole and electron volts. I think question is clear to you all. Yes, question is clear. But you have been given with only one parameter, that is lambda, which is wavelength 234 nanometer. The first thing that you have to do is you have to convert the nanometer into meters. So how can you convert? As already I have expressed in the previous slide, 1 nanometer is equal to 10 to the power of 9 minus 9 meter. So nu you have to identify. What is nu? Frequency in terms of hertz. So let us work out here. So the formula, the knowledge that student should have is this: the formula nu is equal to c by lambda. So c is nothing but velocity of the light, and definitely you have to mug up this value as a student to work out onto the calculation. Or suppose logbook is given to you, then it is helpful. So c is nothing but velocity, that is 2.998, or simply you can keep 3 into 10 to the power of 8 meters per second, and substitute this 234 into 10 to the power of minus 9 meter. Since the velocity is expressed in terms of meter, we are supposed to convert the nanometer in the meters at the earlier stage. And then if you divide, you get this expression. Second inverse is nothing but also can be expressed as hertz. Right? I'm not going to give time for you to do the calculation. Later on, you can work out onto it. And this is what the frequency you work with. So what is the next task that is given? So you can calculate frequency provided the wavelength is given, right? And for that, the student should have a knowledge of value of velocity of light. Is it clear? Is it clear?
Please respond, students.
Yes.
Is it clear? So what is the next
Yes,
task
ma'am.
given?
Yes,
What is the next task given? What you have to find out?
Energy.
Energy. Shall we move on to that? Okay, energy. So something I've written here, 6.626 into 10 to the power of minus 4 into what is this? What is this value? It is nothing but nu. So can you tell me what is this 6.626? Can you give me the formula to
Planck's
calculate energy?
constant.
Planck's constant. So what is the formula? E is equal to h nu. Can we have this formula for this sum? Yes. E is equal to h nu. So h into frequency. So this comes around this. But what is your challenging thing here? Students should have a knowledge to convert joules to kilojoules and also in terms of mole inverse. So you have to report energy in terms of kilojoules per mole. So first step, let us do convert joules to kilojoules. So when you're converting lower to the higher side, you have to divide, right? So joules is lower, kilojoules is higher weight. So kilo means 1000. So you have to divide it by 1000, which is nothing but into 10 to the power of minus 3. So this same expression you are just modifying by incorporating the multiplication with 10 to the power of minus 3, or you can divide it by 10 to the power of 3000. So that will convert joules to kilojoules. So that part is over. Now the next thing is you have to convert kilojoules to kilojoules mole. Right. The same expression I have written here for kilojoules, and one extra fitting is being incorporated here is nothing but 6.023 into 10 to the power of 23 mole inverse. What is this number? Any idea? How will you convert any unit should be accompanied with a mole? What number is being introduced? Avogadro numbers, exactly. So students should also aware of for this Avogadro number. These are all knowledge component you should aware. Then you have to incorporate skillfully into the problem that is given. So that is a skill based attitude, right? And then after the calculation, you can see here the conversion, right? Finally, you get it in the form of kilojoules per mole. And what is the next task? You have to see or report the energy in terms of electrovolts. So this is another expression you should remember. 1 electrovolts is equal to 1.603 into 10 to the power of minus 19 joules. So you're asked to report the energy in terms of electrovolts. So now keep the joules this as such, and just bring the 1.603 below. So 1 by 1.603 into 10 to the power of minus 9. And then you have already calculated the energy in the previous case. You remember this, right? 8.48. And to that, you substitute in place of joules this expression, that is electron volt divided by 1.603. And after calculation, you'll be able to report the energy in terms of 5.3 electrovolts. So this is how you can interconvert the units, as well as per the task given, you can report the answers. Right. So from this problem, you have understood how to calculate frequency when lambda is given, and also you can calculate energy in terms of kilojoules per mole as well as in electron volts. So shall we move on to next problem? So now you are asked to find wavelength. So first let us see how to convert 500 nanometer to meter. Can anybody say this answer? How will you convert 500 nanometer to meter?
Students, you unmute yourself and respond, please. Any one of you.
Just before example, I've told you how to convert nanometer to meter. You have to multiply with
10 power
minus 9. Yes, correct. 10 power minus 9. So let us convert first this into meters. And even this you can write it as 5 into 10 to the power of minus 7 meter. Just a decimal is varied. Here it is 500. Here I made it as 5. then 10 to the power of minus 9 has become 10 to the power of minus 7. So the next question is determine wavelength. The problem is actually to find out the wavelength if the frequency is given. So what is the relationship between wavelength and the frequency? So wavelength is equal to c by nu, right? So you incorporate the value of c, which is speed of light, and also the frequency according to the question, and then you calculate so that you will get this 0.5 into 10 to the power of minus 6 meter. Now you convert this 10 to the power of minus 6 meter into divided by 1000 as well as multiply by 1000, because the expression does not change. When you divide by 1000 as well as multiply by 1000, it will not change. Why we have to do this is you have to make 10 power minus 9 to convert into a nanometer. Please remember, when you are reporting wavelength, you should report in terms of nanometer. But whatever the value that you have substituted here is nothing but meters. Now you have a task to convert this meter to nanometer. So when you look into meter to nanometer, you should have 10 to the power of minus 9 above, right? So we are just adding 1000 here, dividing by 1000. So the expression will not change. Now you just move this 10 power 3 to above. So 10 to the power of minus 3 it comes. So 10 to the power of minus 6 and 10 to the power of minus 3 becomes 10 to the power of minus 9. And 0.5 into 1000 will become 500, right? So you have to understand why we are dividing and multiplying by 1000, because to convert meters to nanometers. So you have to express wavelength in terms of nanometers always, practical point of view. So 500 into 10 to the power of minus 9 meter, which is nothing but 500 nanometer. Right, so here the student should have knowledge of expressing the value for speed of light, and also how to convert meter to nanometer by incorporating the required decimals like thousands or hundreds or even 10,000s based on the value that is already present. Right, so this is problem 2, and this problem is the one where you can convert or find the wave number. Where wave number is used, in which spectroscopy wave number is used?
IR spectroscopy.
IR spectroscopy. So here it is given wavelength as this. So let us do first, as I already said, the unit of wavelength is centimeter inverse, but you see the wavelength is given in terms of meter. So let us first convert the meter into centimeter as below. So 5.89 into 10 to the power of minus 7 meter is 10 to the power of minus 5 centimeters, right? Because you have to convert the higher value to lower value, means you have to multiply, right, into 100. Then what happens? You substitute here 1 divided by this value is substituted, and 1 divided by 5.89 is this value into 10 to the power of 5 centimeter inverse. Just you are bringing it above. This is below, right? This is in the denominator. So 10 to the power of minus 5 becomes 10 to the power of 5. Centimeter will become centimeter inverse 1. Then you can multiply and give the answer. So this is how you are supposed to convert meter to centimeter, and then you can incorporate into the formula. So this formula you should have, where that is nu is equal to, that's a wave number. Actually a bar should be there, nu bar is the wave number, which is expressed as 1 by wavelength. And as I already shown in the terminology, these are the real-time formulas that is used to calculate absorbance. So you should aware of these derivations, as well as what are the different formulas that are available for absorbance to be calculated. So let me just go to the actual problem related to spectroscopical measurements. So you are given with the wavelength, and also what is 1 millimeter represents here? Can anybody say from the question, what is 1 millimeter? What is 1 millimeter? What is 280 nanometer? It's a wavelength. It's given in the question. Passed through 1 millimeter. So what does it represents? It represents a cuvette. Thickness is 1 millimeter, right? Then concentration of 0 point. Obviously, concentration is given directly. Concentration is given, and light transmitted, reduced. The light intensity reduced means something after absorption it is coming, right? So transmitted light. So percentage transmittance is given as 54%. So you have a value of wavelength, thickness, concentration, and transmittance. So let us see what the expectation from the question. Calculate the absorbance and molar absorption coefficient. These are the two tasks given to you. So first thing that you have to do is list out what all the things given. So thickness is given as 1 millimeter. Probably you convert into centimeters. Then concentration is given in millimoles per liter. You have to express the molar coefficient in terms of moles per liters per centimeter, right? The unit that is required for molar absorptivity is moles per liters per centimeter. So that is why you are converting millimeter to centimeter at the first step. And also you are converting millimoles to moles. You can see here how it is converted into 10 to the power of minus 3. Millimoles is converted to moles here. And also you have calculated T from 54%. That is 54 by 100 is nothing but 0.54, the transmittance value. So now you can take up a very simple formula for absorbance. A is equal to minus log T and A is equal to log 0. So when you use a calculator, scientific calculator, press log and then 0.54, you get a value of 0.27. So now you have calculated the absorbance, which is the first task from the question. Now let us move on to the second task. What you have to calculate? What you have to calculate? Second task?
Molar absorbance.
Absorbance. Can you give me a formula? This formula can be used because you have calculated the absorbance, you have provided with thickness, concentration also given. Can you go with this formula? Yes or no? Capital A is equal to epsilon BC. That was a formula according to Beer-Lambert's law, isn't it? A is equal to KBC. K is a proportionality constant. Molar absorptivity is also a constant, right? So when you apply this, absorbance already have calculated. So give the value for thickness and also concentration. And finally, you can arrive at this answer. So you please go through later on how the conversions and other things is taken place. I cannot discuss every step of the calculation. Just I'm giving you hints how you can step further to arrive at the results, right? And then next is what is the percentage of T of a solution absorbance? So what is given here? What is a given parameter? Absorbance. What you are asked to calculate?
Transmittance.
Percentage, not transmittance, percentage transmittance. Please be careful with the question, right? Percentage transmittance. Is there difference? Is there difference? Transmittance and percentage transmittance are different or same? They're different, right? So now you have to aptly use the formula. The student should have a knowledge to aptly use the formula. A is equal to minus log T. So keep T here and just take the log to the other side. So anti-log of minus A. So A is given as 0.764. And when you take anti-log of minus 0.764, you get this value. So how to do anti-log in the scientific calculator? Press shift and then log. Shift and log and then give the value minus 0.764. That is how you can calculate anti-log in a scientific calculator. Press shift log, then minus the value. So you get transmittance, but you're asked to calculate percentage transmittance. So you can multiply it with 100 and it gives you the answer. And the next problem is related to calculating the concentration, right? You're asked to calculate concentration and in particularly you wanted to represent in microgram per ml. So that conversion is very important. Let us see how it takes place. And you have given a molecular weight. What else is given? Wavelength, absorbance, thickness, that is path length, and also molar absorptivity value as 543T. So these are the various parameters given and you are asked to find out concentration, right? So let us see how. So these are the things that are given. I have just described here. And first thing you have to know what is a formula that is employed for concentration. What is concentration? What is concentration? That is a determination. That is what we have to calculate from the question. So C is equal to A by AB. Now you look at the parameter. What all is available? Okay, A is available. You can incorporate. B is also available. You can incorporate. Small a is available in the question. Please answer, students. Small a. What is small a? I've discussed this in terminology. What is small a? What is small a? Specific absorbance or A 1% 1 centimeter value. So this small a is nowhere given in the question. So now the first thing that you have to do is you have to find out small a. Now let us take this formula. This formula is available. Epsilon is equal to A.
I am Prachet from assistant professor from Tirupati College, madam.
Tell me, sir.
So time is running out, madam. Just 20 minutes is there. Can we shift to Woodward-Fisher rule, madam?
Woodward-Fisher rule, sir. Shall I skip off this calculations part?
Yes, madam. So we have discussed about 3 problems right now. We can skip this problem.
Okay, then. So I've given the summary, so you can just go ahead. You can refresh with the formulas that are available, and then as time is running short, I'll move on to the third part, that is Woodward-Fisher rule. So this rule, the basic objectives of this rule is you will be able to enter the basic or parent values, and also you can able to substitute increments for different substituents or groups. You can identify exocyclic double bond, you can identify ring residue, extended double bond conjugation, differentiate cis trans isomers, as well as you can calculate absorption maximum. And specifically I have taken examples with respect to dienes, unsaturated carbonyl compounds and aromatic compounds. So I'll just skip this part. These are the two scientists who have developed the rules, and it has been experimentally proven by the second scientist, that is Fieser. And now let me move on to the actual content related to conjugated dienes. If a diene or triene is present in any structure, the first thing that a student has to give is a base value or parent value. So this is very important, the first step, and these values you can infer from the reference table that is available with books or any other references. So apart from base or parent value, the contributions are towards the alkyl substituents, ring residues, double bond extending conjugation, and also you have some polar groups like halide groups, which also gives contributions to the lambda max. So you have to remember the base value or parent value as a first step, and then the other contributions to calculate the lambda max theoretically for a Woodward-Fisher rule. So in the conjugated diene, you should understand what is homoannular diene. When a conjugated dienes are present in a same ring, it is homoannular, and if it is present in a different ring, it is a heteroannular. And suppose if you have some structure where you have both homoannular as well as heteroannular, will contribute towards the absorption. And when a ring is containing any double bonds inside, then it is called as endocyclic. And if it is specifically present outside the ring in the sense, if you consider here two rings A and B, so A ring, you can see outside A ring there is a double bond which is confined to B ring. So A ring has an exocyclic double bond, but B ring does not have an exocyclic double bond. So that is how you can identify the exocyclic double bond when two rings are connected to each other or fused together, right? So in the conjugated diene, these are the reference table from which you can take. Generally, homoannular diene carries more basic values, 253, heteroannular 214. Suppose you have any structure with hetero as well as homoannular, it is around 253 nanometer, because the highest value is actually incorporated for the calculation. And if you have alkyl substituent or ring residue, then 5 nanometer. For double bond extending conjugation, it is 30 nanometer, and for exocyclic double bonds, 5 nanometer. And for other groups, as per the table, you can incorporate. So these are the very important values that you have to compulsory memorize as a student to calculate it. So now you can see the difference between the base value for homoannular as well as heteroannular. Heteroannular it is less, and homoannular it is more. And the first thing that a student should do when a structure is given, you identify the conjugated area. So see the conjugated area here, it is 1, 2, 3, 4. This is the area. And in case of homoannular, 1, 2, 3, 4. So the first step that you have to do in predicting the lambda max theoretically by using Woodward-Fisher rule is number the conjugation. So after identifying the conjugation, you have to give importance to the increments like exocyclic double bond, ring residue, and other polar groups, as well as the extended conjugation. Let us see one by one. So exocyclic double bond, as already I've told you, for ring A, the exocyclic double bond is this one, right? For ring B, you don't have any exocyclic double bond. So how will you identify exocyclic double bond? You have to just you have to round your eyeballs to 360 degrees so that you see outside this ring any bond is connected. So that is a exocyclic bond. So in case of A you have, whereas in case of B you don't have an exocyclic double bond. Then you can see the change in the position of the double bond. So here the position is here in this left ring, that is A ring, and here the position in the right side of the A ring, right? But the wavelength is varying. So what could be the reason for variation of this nanometers? So let us look into that. So I've taken an example of the first compound where you have to number the compound. So it is homoannular or heteroannular? This structure is homoannular or heteroannular? This is homoannular, where you have both the dienes in the same ring, right? So this is a base value, 253 is given. And the next thing that you have to understand is identifying the ring residues. So what do you mean the ring residue? Residue means something it is left out. So these rings are bonded to the conjugation and it is left out from the conjugation. So this is the area of conjugation where the bonds are connected to the next ring that is called as ring residue, which is not involved in further extension of the conjugation. That is called as ring residue. So you can see here a conjugation ends here at 1 and 4, but it is extended to other fused ring, but it is not involved in the conjugation. That's why it is called as residue. So for each residue you have to give 5 nanometers. So 10, that comes around 263. So when you take the next compound, see the position of double bond is different here. And of course, it is also homoannular, where you have given the base value as 253 nanometer, but it has 4 ring residue. See here, 2 as well as the next side 2. So these are the bonds that are left out after the conjugation. So 4 ring residue, you have to give 20. And also you can see the exocyclic bond here. For B bond, B ring, you have an exocyclic bond here. So for that you have to give 2 exocyclic bond, 2 into 5, 10. And for A ring, there is no exocyclic double bond outside. So altogether, you can see the difference of 20 nanometer from the previous structure because of presence of 2 more ring residues as well as 2 exocyclic double bonds. So position of double bonds also matters to or increase to the wavelength. And the next is presence of substituents. So the first thing that you have to do for this structure is you have numbered the conjugation area, and also you have identified the various ring residues in the rings. And the next thing that you have to consider is the presence of substituents. The substituents here is alkyl substituent, that is methyl group, for which we have given 5 nanometer, and for 4 ring residues, 4 into 5, 20. And this is a heteroannular, so the base value is 214. And with respect to A ring, you have 1 exocyclic, and also with B ring, you have 1 more exocyclic. So everything is incorporated, and you have summed up the value finally. But you can ask me why this alkyl group, 2 alkyl groups which is in the A ring, is not accountable for the calculation, because it is not involved in the conjugation. It is very far away from the conjugation. So unless otherwise any alkyl substituents is attached to the conjugation, then only you can give the increments for those alkyl groups. Otherwise it is not required. And next is double bond. You can even work out onto this here. The extension that I wanted to add up here, apart from ring residue and also apart from exocyclic double bonds, you have an extended double bond. So conjugation is nothing but 2 double bonds and 1 single bond. Suppose if it is extended with 1 more double bond, then 30 nanometer has to be given as an increment, and you can sum up finally to get the answer. And next, I've taken an example of acyclic dienes. Previously, I've seen a cyclic dienes. In acyclic dienes also, you have to number and look at the number of alkyl groups that is present in the conjugated area. So here 3 alkyl groups are there. So 3 into 5 becomes 15. And your base value for acyclic diene is 217. So as of now, you understood the base value of acyclic as 217, heteroannular as 240, and also homoannular as 253. And also you have understood about the various substituents like ring residues, exocyclic, extended double bond conjugation, as well as the alkyl substituents towards the lambda max. And cis and trans conformations are very important to study. Trans is something which is opposite double bonds, and cis is on the same side. So the trans conformation will lead to heteroannular structure, and cis conformation leads to homoannular structure for any cyclic dienes. That is why heteroannular absorbs at lower, shorter wavelength compared to that of the homoannular. Why? Because you have many ring residues here as well as the double bonds. So 20 more here is due to what? Anybody can say how this 20 is accountable for this structure? So this is a base value. How does this? How many ring residues? 1, 2, 3 ring residues. Not 4. 1, 2, 3 ring residues are there, and you have 1 exocyclic double bond, right? So 15 plus 5, 20. And here you have 1, 2, 3, same, and also 1 exocyclic double bond. So 3 ring residue and 1 exocyclic double bond contributed to 20 nanometer. Thereby it gives you the more lambda for the homoannular diene because of the cis-soidal isomerism. These are the sums I have just posted here. You can just work out later on when I share to the organizers. So here base value ring residue and exocyclic double bond is incorporated. And next we'll move on to some examples related to unsaturated compounds. So here we can divide the base value into three categories: acyclic, 6-membered, 5-membered. Acyclics 214, 6-membered 214 or 215, not much difference, but 5-membered has only very less value, 202. Apart from that, you have to contribute towards the other increments like substituents, alkyl substituents or ring residue at alpha, beta and gamma, delta. This is a very important difference from the conjugated diene. In case of conjugated diene, you are given for all alkyl substituents and ring residues 5 nanometer. But here, since we are taken example of alpha, beta unsaturated, something which is related to a position of the functional group, then your values also will vary. At alpha, it is 10, beta 12, and higher than that is 18. Apart from that, the double bond extended conjugation as well as exocyclic double bonds are accountable. And these are the other values which you can incorporate while working out. And this one example I wanted to show you, it's a base value for this. This is a cyclic ketone. So 214 is a base value. And you can see, so the first step that you have to do is just mark the position alpha, beta, gamma, and delta. So what is alpha? Next to the functional group is alpha, beta, gamma, and delta. So here you can see there is no ring residue, but in beta position you can see one ring residue, gamma no ring residue, and at delta position one ring residue. So total 2 ring residues, but for alpha you are supposed not to give any value. For beta it is 12 nanometer, and for delta it is 18 nanometer. And also you can see the extended double bond. Apart from 2 double bonds, you have one more double bond. So double bond extending conjugation also has a contribution. And also you can have one exocyclic double bond, which is for 5 nanometer. So when you are working out with alpha beta unsaturated compounds, you should have to number the compound not with respect to 1, 2, 3, 4, but with respect to alpha beta gamma position. And also you have to incorporate exocyclic ring residues as well as the double bond extending conjugations. And next is this is another example for aldehyde, that is acyclic. You can do 207, and you have to number accordingly. So you have beta position one alkyl substituent and also one ring residue, and in alpha position you have a alkyl group. So alpha it is 10 nanometer, for beta it is 12 nanometer, and ring residue at beta position is also to be given as 12 nanometer. So likewise you can work out on many structures.
These are all examples of terpenes,
Yeah, terpenes, carbones, citrals I have taken.
Yes.
I'm sorry, I could not take much time. I don't know.
Yeah, it's okay.
I'm a shortage of time. I could not elaborate the calculations part. If you want, I'll share the PPT so that they can work out onto it later on.
Sure, ma'am. Sure. I have shared with them.
Yeah, this also I will skip because I have to go with aromatic compounds. So aromatic compounds, basically the chromophore which is responsible for absorption is benzene ring. Apart from benzene ring, some substituents as well as the carbonyl related functional groups, like say for example aldehyde or esters or acids, which predominantly undergo pi to pi star transitions, will have more absorption in the UV spectroscopy. And these are the basic values, especially for aldehyde you have to incorporate 250, for that is acid or ester 230, and for ketones it is 246. So base value obviously the student has to memorize, and some of the increments also it is must if they are working on to the specific compounds. And this is a table again describes the various values. And importantly, I've just marked here in green, which I'm going to use it in the future, that is problems we are going to discuss. Just I'll move on to the problems. The first example that I've taken is para-aminosalicylic acid. It's an anti-tubercular agent. This is a structure. So you all know that salicylic acid is a hydroxybenzoic acid. In the para portion, you have an amino group. And of course, it's an aromatic compound with a chromophoric nature, and it has a base value 230 according to the table. And you can see in ortho position hydroxy group for which 7 nanometer, and in the para position amino group for which 58 nanometer. And please understand, when you are elucidating or interpreting the aromatic compounds, there is no role for double bond extension or kind of this thing exocyclic or endocyclic double bonds. That's not come into the role here. So only you have to bother about the substituents and their values. So this is the 295 nanometer, and I just wanted to show you the spectrum that is actually practically obtained for this particular compound. You can see the lambda max at 3 nanometers, and the calculated lambda max is 295 nanometer. So that is how you can infer or identify your compound with respect to the rule. And the next one is para-aminobenzoic acid. And this compound, the base value is 230 as earlier, and you don't have OH group is missing from the previous, isn't it? Previous you have OH, but here the OH, one important oxochrome is missing. That's why you can see the shift of lambda max towards the lower side, because 7 nanometer is missing here. So your value is obviously less. This is because of the absence of another important oxochrome OH. That's why you're getting a 288 nanometer compared to para-aminosalicylic acid. BABA absorbs at lower wavelength. And I've given the reference for this because simply I cannot give any spectrums. The apt spectrum has been displayed here. And this is a reference from which I have taken the spectrum of BABA, where you can see almost 280 to 288. Definitely there will be shift in the lambda max. Whatever we are theoretically calculating, we are not able to get it practically because so many factors involved there, especially the solvent. The solvent which you change for your analysis definitely makes a shift in the lambda. And the next example is related to ketone. You can see here the phenone, for which 246 nanometer. And the very first thing that you have to do is you have to number the ortho, meta, and para position. And you can see this is ortho, means this is also ortho, right? Both are parallel. So ortho position where ring residue is given. So ortho ring residue is 2 nanometer, and you have a para amino group for which 58 nanometer, and total it comes around 306 nanometer. So it is important that you have to give the base value and also the values for the substituents, and the position of the substituents also matters when you give the values. And this is parachlorobenzaldehyde. Benzaldehyde means the base value is 250 nanometer, and parachloro position 10 nanometer is given. And very interestingly, you look into the other compound where 3-chloro, that is ortho, meta, and para position, that is trichlorobenzaldehyde is there. But when you look into ortho and meta position, the chloro does not contribute any nanometers, 0 it is kept there. So you cannot see much differentiation from monochloro and trichlorobenzaldehyde. So it is very difficult to differentiate or identify these two compounds by UV spectroscopy. You have to go for IR or any other spectral studies, because the contribution of chloro at ortho and meta does not give any increase in the nanometers. So that is also lacunas behind the interpreting using Woodward-Fisher rule. So this is a spectrum. You can see parachlorobenzaldehyde, which is what we calculated is around 260, but here there is a shift, maybe due to any other factor, the experimental condition, the analyst error, so many things are reasons for this. And this is a spectrum of benzaldehyde where you can see exactly 250 nanometer for aldehydes. Base value for aldehyde, as I already said, it is 250, you can see here. But because of the presence of chloro group, it is slightly shifted to the longer side. So that is how you can interpret different types of compounds. One acid compound I've taken, so which is a broma acid compound, where for acid it is given the base value as 230 nanometer, and here you have a para ring residue as well as meta ring residue for which different values are incorporated. It is not same like your conjugated dienes to give 5 nanometer. Here it is varying based on the position. When it is nearer, it has more value. If it is far away, then it has a less value, like that. And also you have bromo group at the meta position which carries 2 nanometers. So for this interpretation, definitely you require a reference table so that you can incorporate the values and finally sum up to get the theoretical value, and also you can compare this theoretical value with respect to practical contents. And of course this rule has some limitations, like suppose if you have a phenolic compound or any nitro compound, and this is a structure of picric acid which is nothing but 2,4,6 trinitrophenol, where you don't have any basic values for phenolic compounds or nitro compounds. And obviously when you look into the, as you all know, the color of picric acid is yellow color, definitely it absorbs at visible radiation. That's why it is not accountable in the UV spectroscopy. Mostly the colors, the compounds are colorless, then it can be better interpreted in UV compared to that of the visible spectroscopy. So with this, the summary, so in all the categories, you have to enter the base value, and also you have to look into for entering the values for alkyl or ring residues. In case of conjugated diene, it should be same value, but in case of unsaturated compounds and aromatic compounds, it varies based on the position. So here it is alpha, beta, gamma, and delta position, whereas in aromatic compound, it is ortho, para, and meta position. And in first and second cases, you have an increment with respect to double bond extending conjugation and also exocyclic double bond and other ring residues, whereas you don't have any contribution of exocyclic double bonds and conjugated extension in the aromatic compounds. So these are the references that I have referred for this particular. So it's a very extensive topic, and I'm sorry I could not make it possible within the time. And these are the two assessment link. I hope that I have done justice, and I'm really not happy with the time. I could not able to complete most of the calculations part, that the hints and tips that I really like to give to the students. It's missing.
We will share this presentation, madam. No issue.
Yeah.
We can
So
share
please,
it.
please don't fail to attempt this links I prepared for the students. So then only I can infer that how far they have understood and they're able to, how far better I delivered the content also, I can know from the response of the students. So I thank once again for the opportunity. Thank you one and all.
Dear students, do you have anything specific to ask? Interact with madam, please. One or two we can take up on this Woodward-Fisher rule, either in the aliphatic system or in the aromatic system. If you have, do you have any queries, please feel free to interact. Another 5 minutes we can spend. Yes.
Yeah, I'm ready to take up the question. Please come out with some questions.
You please unmute yourself and you please ask any of the slides. Any doubts you have, queries, you please. I request even faculty members could also interact with madam. Only will post in chat box. Huh?
Your questions are posted in chat box?
Still I am not received, madam.
Okay.
Madam,
So
regarding conjugated dienes,
yeah.
There will be two base values. There will be two base values, madam. For the acyclic dienes, there will be a 217 parent value. And for the cyclic dienes, with respect to the two factors, that is homoannular and heteroannular.
Yeah. Yes, sir.
Is it right, madam?
Yeah, acyclic you cannot give 253, the highest value.
No, madam.
Acyclic is 217.
217 is the parent value.
Yeah, parent
so if at all a molecule given example is acyclic diene, then we can go with the acyclic diene. But
yeah, 270 nanometer.
What my question is, if it is conjugated diene with acyclic and cyclic molecule, then what should we consider? Whether we go with the parent value of acyclic diene or 217, or with the cyclic diene.
Which means you're talking about the combined acyclic and cyclic dienes kind of structure?
Yes, madam. Yes, madam. If at all structure contains in that way.
Yeah, you have to go with a higher value.
Okay, then we should go with the homoannular 253 base value.
Yeah, that is what I told. Hetero and homo, or it is cyclic or acyclic. If it is a fused ring structure, whichever is higher value, that has to be contributed, because that gives contribution towards the absorption of a radiation.
Okay, madam. So another question, madam, if at all there is an double extended conjugation,
you have to add one more. You have to add one more 30.
Plus 30 plus. It is okay, madam.
See, the minimum conjugation is 2 double bonds separated by 1 single bond. Apart from that, if you have any more double bonds, but see to that they are in connectivity to the conjugation. Suppose if conjugation is missing, you cannot give 30 nanometer for that extension.
Okay, okay, madam. But my question is, if at all it is more than double conjugation, or like 3 or 4, which means that after 3 or 4 conjugation, then it can be a Fisher-Kun rule. Because
you can even interpret that, but I have given an example for only minimum here. I have not talked about that rule.
No, madam. My question, I am asking about the question, not in the PPT point of view, but I am asking about my own interest.
Yeah. Yes, you can go ahead with that rule.
Okay, madam. Thank you.
For example, if you take an example of vitamin A, A1 and A2, you have more number of conjugated dienes that you cannot rule out with this Woodward-Fisher rules.
Okay. Thank you, madam.
Thank you, Peter sir, for your interaction. Any other students, faculty members?
I think since the time is not sufficient, students are not like interacted towards the rules, because I quickly rushed out it.
Whatever that link you have shared, madam, please share it in the Gmail in our department. Definitely, I'll share that link with our students.
Okay.
Definitely, they'll yeah.
Should I put it in the chat box or I'll share to your this thing?
You can share it to our mail ID, madam. I will share with through WhatsApp also. I will share with my students.
Okay.
So, with no more further discussions.
Sure.
Yes, yes, ma'am. Please introduce yourself and post the question.
Good evening, ma'am. You have given an informative session today. I have a small doubt. Is this UV spectroscopy can be applicable in pharmacokinetic of a drug sample?
Yeah, definitely it can be applicable. You can study the drug release. So you are performing the drug release using dissolution, isn't it? Dissolution apparatus. The released drug can be estimated by UV spectroscopy.
Impurities can also be found, ma'am.
Which one?
Impurities.
Yeah, impurities also you can estimate.
Okay, ma'am.
But I think they should impurities also should have that chromophoric groups, madam. Is it?
Yeah, definitely.
Yes.
If the impurities have anything that can only have an ability to absorb will interfere.
Yes, yes.
And that interference also you can study with many other quantitative techniques like the absorbance ratio method and other multi-component methodologies are available.
Yes.
Q ratio methods and so by that you can infer. Qualitatively, how can you infer impurities is just your spectrum may go blurred or additional peaks due to impurities you can see. So that is how you can identify impurities. I have not touched the qualitative and quantitative applications, only this calculations and Woodward-Fisher rule is the mainly.
But it was very interesting, madam. Quickly, you have shifted the slides. Immediately, the students could post the answers rapidly.
Actually, I have not seen the time, how much it has been. I'm having or running out of the session. But I actually expected 1.5 hours to 2 hours. That is what I planned, being a workshop kind of thing. It's a simple lecture means I would have able to complete it within 45 minutes, 1 hour. Being a practical
but you have shared a lot of information, madam. Good amount of information from the basics. You have shared
personally, I feel that I could not able to cover the scope. So I thought of telling more on the calculations and Woodward-Fisher, but still without knowing the terminologies, they cannot without knowing the formula, they cannot understand. Just I can read out and go, but that won't be a right way.
Madam, one of our faculty has one more query. Sivaprasad sir, please.
Good evening, madam.
Good evening, sir.
Good evening, madam. One question, madam. Good lecture, madam.
Thank you, sir.
Sometimes theoretically prove the nanometers, madam, based on the rules, but sometimes practically not met the theoretical values, madam.
Definitely, it is not possible. Just it gives you an idea. Why? Because let me tell you, sir. Why? Because even though if you are properly following the procedure, there may be definitely shift in plus or minus 2 nanometer in a practical perspective. And moreover, there are other factors. Your stray light can interfere, your errors in the preparation of the solution, or your reagent quality, your substance quality, and also your solvent. Suppose you have used sodium hydroxide instead of HCl or something like that. If you vary the solvent also, your chromophoric nature will definitely vary. So there are too many, even your slit with everything that deviates the law is responsible for deviating your wavelength also.
Madam, sometimes a solvent effect is also there, madam.
Yeah, definitely it is there. When you change the solvent, there will be shift in your lambda.
Thank you, madam.
Yeah, thank you.
Thank you, sir.
Good lecture, madam.
Thank you.
Dear students, anybody else have any queries? Yeah, students or faculty members. Do you like to have any interaction with madam?
Yes, ma'am. One doubt.
Yeah.
Yes, ma'am. Introduce yourself, ma'am. Please introduce.
I am Preeti. And isobestic point is the point where all are coincide in the graph. is it that there will be only one isobestic point, or we can have many isobestic points in a graph?
That's a good question from student point of view. See, actually what the spectrum I posted has one isobestic point. It is not necessarily that only one isobestic point should be there. It depends upon your nature of the spectrum. So if your spectrum has two or more than three parabolic curves, and the second compound has more than four parabolic curves, obviously it will intersect at many points, right? So there is possibility of having even more than one isobestic point. You can choose any one of the isobestic point for the estimation. And even that has to be properly validated according to the guideline, whether that lambda or isobestic point is feasible for the study. So that's all extensive research. When you undertake your project in analysis, you might be able to understand better that. But your question, I think I've answered. There is not necessarily one isobestic point. Definitely, if you have more chromophores and more absorption bands are there, there will be more isobestic points.
Okay.
Yeah. So see, I request the students, still if you have any queries, you please, you can post it in our student group, in our WhatsApp group. I could share with madam, right? We could have an interaction. And I request madam to share your mail ID also, madam, so that if our students have any queries, they will post your mail ID.
Yeah.
So that whenever your free time is there, you could please answer the questions, madam.
Definitely,
yeah. So
sir.
with this interaction, so I thank you, madam, for spending your valuable time. Since almost 2 hours, you have been interacting with our students. So really, it was a brainstorming session for not only the students, even the faculty members. So it was a really wonderful presentation here given. It's a very useful presentation. So those, especially the picture-wise representations you have given, and you asking them to identify what kind of a terminology it is in analysis, so that students have responded well. So definitely, I appreciate all the students who have responded to the questions posted by the speaker. So definitely that will create a kind of a very good interactive. See, a session should be an interactive session, not like one person talk, the other person listen, and there ends the session. It should not be like that. So definitely, this was one among the best interactive sessions. So I thank all the students who have interacted with the guest speaker. I thank the faculty members also who motivated the students to interact with the speaker. So on behalf of our institution, Chalapati Institute of Pharmaceutical Sciences, on behalf of our management, Sri Vaivi Anjaneyulu garu, our chairman, Chalapati Irrigation Society, on behalf of our beloved principal, Professor Ramarao sir, and on behalf of all the faculty members, all the faculty members of the various other departments of our institution, I once again thank you, madam. So thank you for spending your valuable time, and thank you for spending so much time in preparing the slides in such a very interesting way, so that it will create a kind of interest in the students. Thank you, madam. We hope for another session in the future with you. Whenever you are having a free time, definitely we'll contact with you and we'll have another session with you, madam. Thank you so much, Dr. Vinodini, madam. Thank you, madam. So we will end the session here.
Thank you very much, sir.
Thank you, madam. Thank you. We will end the session here, madam. Thank you.
Okay, sir. Thank you.